today we're doing lesson 6.4, numerical patterns. Andre's class is choral counting by 10 and then 9. The left column shows the numbers they say when counting by 10. Complete the right column with the first 10 numbers the class will say when counting by 9. So what number would they say first? 9. Write this down. And then
18.
Keep going.
27.
Keep going.
30.
Come on, guys, everybody. You guys know these. 36.
45.
45. 54. So 9 times 1 is 9. 9 times 2, 18. 9 times 3, 27. 9 times 4, 36. 9 times 5, 45. 9 times 6, 54. 9 times 7,
63.
9 times 8,
72.
9 times 10.
90.
Oh, I skipped one. 9 times 9.
81.
And then 9 times 10. 90. Okay. So, look at those numbers. I have decided that my new lucky number is going to be 9 because I love the nifty nines trick. I also think it's really cool that, need to hustle up. Look at this. So look at the tens place first. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then look at the ones place. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And then another cool thing about the multiples of 9. What is 0 plus 9?
9.
1 plus 8.
9.
2 plus 7.
9.
3 plus 6.
9.
4 plus 5.
9.
So the sum of the digits on the on multiples of 9 equal 9. They add up to 9. So the patterns that we notice, this is kind of cool. What do you subtract from 10 to get 9?
1.
What do you subtract from 20 to get 18?
2.
What do you subtract from 30 to get 27?
3.
What do you subtract from 40 to get 36?
4.
What do you subtract from 50 to get 45? So that's another cool thing when you're putting 10s and 9s side by side. They have a pattern that way too. So we're going to make at least 2 observations about each list of numbers. Evan.
I figured something out.
Okay.
I figured that every single one on the bottom on the same one, so there's like on 2 there's 18, and on 90, like on 20 there's 18, and on 90 there's 81. It switches numbers.
Yeah. Yeah. Oh, yeah. You mean that 1 and 8 and 8 and 1 and 2 and 7 and 7 and 2. Yep. Yep. It's pretty cool. They flip flop. That's another thing. Yes, I forgot to mention that. So 0, 9, 9, 0. 1, 8, 8, 1, 2, 7, 7, 2, 3, 6, 6, 3, 4, 5, 5, 4. Very cool, right?
Yeah.
Okay, that's why I think 9's going to be my new lucky number. And I was born in the 9th month. It's official.
September.
Yeah. Okay, here we go. So I want you guys to write, it says to write down 2 observations about each list of numbers. We're just going to write down that the tens place increases by 1 with each new number. Zarella, you better be writing. The tens place increases by 1 with each new number. Okay, so that observation covers both of them. And instead of doing 2, we're just going to do the 1 for now. Because we've talked about several more. For the numbers in the counting by 10 column, why do you think the digits in the tens place change the way they do? We're going to take a good look at how, what happens when we add 10 to a number. So if we start with, if we're adding 10, what digits in the ones place? 0. So that means every number that you add 10 to, the ones place doesn't change, right? Because you're adding 0. And then when but the digit in the tens place goes up by 1 because in the number 10, it has a 1 in the tens place. Colton, sit up, please. Okay, so the digit in the tens place change. Why does the digit in the tens place change the way it does? And here's what I'm going to have you write down. Okay. Because adding 10 means adding a 1 to the tens place. Because adding 10, thank you, Colton, means adding a 1 to the tens place. And then the digits in the ones place are the way they are because adding 10 means adding a 0 in the ones place. Because adding 10 means adding a 0 to the, not a 0, adding 0. I'm going to erase that A. Adding 0 to the ones place. I'm also going to teach you some tricks for how to add big numbers. So you guys know that if you're counting by 9s, right? 9, and you want to add 9 more. 9 is the same as 10 minus 1, isn't it? Mm-hmm. So is 9 equal to 10 minus 1?
No. Yes.
10 minus 1 doesn't equal 9? It does. So this is what I'm trying to get you guys to see. If you're trying to increase by 9 each time, an easier way to do it is to add 10 and then take away 1. Add 10, then take away 1. So if you're, so for example, we know that 1 times 9 equals 9. We're trying to find out what 2 times 9 is. If you're doing your facts and you can't remember, okay? You can start by adding 10. What's 9 plus 10? 19. And then take away 1. 18. Okay? If we are trying to do 3 times 9, and we know that 2 times 9 is 18. What's 18 plus 10? 28 minus 1? 27. Huh? Right? All right. if you're trying to do 4 times 9, and you know 3 times 9 is 27, add 10 to 27,
37.
minus 1.
36.
Okay? So it's just, because in a minute we're going to add 99. So how would you do that, Harbor? What do you think? So if you're trying to add 99, what's an easy number to do first? What number is close to 99? No, an easy one to work with. 100. And how do you get from 100 to 99?
You subtract 1.
Subtract 1. Okay, so I'll show you in a minute. It's pretty cool. For the numbers in the counting by 9 column, why do you think the digits in the ones place change the way they do? They go down each time, right? So they went 9, 8, 7, and that's because adding 9 is like adding 10 then subtracting 1, which is why the ones place is decreasing by 1 each time. So that's what you're going to write on this next page. Like I said, there's a lot of writing today, but normally we don't have a ton of writing in our lessons. Because adding 9 is like adding 10, then subtracting 1, which is why the ones place is decreasing by 1 each time. Just looking ahead from here. Yeah, I'll put it back up in a little bit. Count by 99. So look on the next page. Just count by 99. Andre's class did a choral count by 99. That means all together, out loud, they counted by 99. That's kind of hard to do. So, it says here are the first 6 numbers they said. Study the list of numbers. Make at least 3 observations about features of the pattern. I'm not going to make you write down the 3 observations, but we're going to talk them through. So, the first one is 99. If we had a 0 in the front, in the hundreds place, what's happening to the hundreds place? Jackson?
It's getting bigger every time.
By how much?
100.
Yeah, or by 1 if you just are looking at the digit. Yes. So if we're just looking at the digit, it's 0, 1, 2, 3, 4, 5, right? Okay, what do you notice about the tens place digit? Colton?
It stays the same.
Always, right? Very good. Okay, and then what do you notice about the ones place digit? Devin?
It gets smaller by 1.
Exactly right. It gets smaller. 9, 8, 7, 6. Okay. So if you see that pattern and you know that, I'm going to write this down, but you don't have to, but you can if you want. So I'm going to write tens place. Adds 1. No. That would be hundreds place. So let me do something. hundredths place, hundredths place. We add 1. Tenths place stays the same. And ones place, like Devin said, goes down by 1, right? 9, 8, 7, 6, 5. Okay. Why is the tens place staying the same? Fisher?
Because
It's kind of weird, right? Because
yeah.
if you think of 99, it's like, why would the tens place be staying the same? Because we're adding 9 to it, right?
Oh, using. Wait. Oh, wait.
But what is 99 equal to? I told you a minute ago. 100 minus 1. It gets bigger by the 1 in the hundreds place, smaller in the ones place, but look at what's in the middle. It's like, so if we're adding 99, it's kind of like we're adding 100, taking away 1. And so if we add 100, the middle place just stays the same. Okay, well let's apply the pattern and see if it keeps working. Okay, 594. Who would like to tell me what number would be the next one in this pattern? Jackson.
693.
693. Yep, it follows the same pattern. This is bigger than that. This is smaller than that. This is the same. Fisher.
792.
Yep, 792. Okay, Mary.
891.
Yep, 891. Devin.
600.
Oh, look what's happened in the hundreds place.
Oh wait, 1000.
No. What's one more than 8?
9.
9.
990.
Yes, that would be it. Okay. Pretty cool, right? All right. Yes, Athena.
I noticed something.
What?
At the top, 99 with the 0 just needs to be added to the back.
Oh. 099 990 198 891 297 792.
Do you want me to give myself a point?
Yes, Colton, you can too, because you pointed out it's every number. Just like on the 9s, the 99s do some cool stuff too. See, I'm telling you, my new lucky number.
If we did
Okay.
it with 100, would it still be the same thing with the tens?
Huh?
If we did it with 100, if we did 10 with the last one, would it still be the same?
Well, that's what we just did. So we added, on this one, we added 100. So 594, we added 100, 694, and took away 1. Does that make sense? I wonder, and this is just a question, what if we were counting by 999? I wonder, let's see what we got. Okay, so we would add 1,000 and take away 1. So this would be 1,098. Then 2,097. Then 3,096. Then 4,095. Oh my goodness, look what I'm seeing. Okay. 1 8 0 9 2 7 3 6 4 5.
It's going down.
It's still going down.
You just add them up again and they equal.
And then this is
Wait,
still
they're
the
going by
exact same.
ones. 1, 2, 3.
Well,
is
yeah,
crazy.
So
My line has been blown.
So watch. What is what's 9 times 1? It's 9. What's 9 times 2? 18. What's 9 times 3?
27.
9 times
Take
4.
out the
36.
I get why
Bruh.
take out the big number.
And then 9 times 5 is 45.
Isn't that cool? Okay.
Wow.
Wait, does that work with the
Olivia,
99?
is your mind blown?
My
brain
has
Okay.
I think it has to be
All right. So why do you think the numbers change the way they do? We're I'm going to shorten this, I think, a little. We are adding 100, then subtracting 1. So the hundreds place goes up by 1. The tens place stays the same. The one place goes down by 1. I'm going to take off this.
Oh my gosh.
Okay. All right. And then I think what I'll do, guys, is just since I'm making a video, I think what I'm going to do is just hold off on making you copy all this down. I'll put it back up when this is done so everybody can have more time to get copied down. Because now we want to go on and count by 15. So we've counted by 9s. We've counted by 99s. And now we're going to count by 15s. What do you think is, what cool trick do you think I'm going to tell you for 15? I've actually told it to you before. What do you think, Athena?
The nifty 9.
No. That's for 9s, not 15s. Macy? And then, yes, girl. 15 is made up of a 10 and a 5, right? So, 15 times 1, and then if we're starting at 15 and we add a group of 10, that would be 25, plus 5 more, 30. Plus 10, 40, Cameron. 45 plus 10, 55 plus 5, 60. 60 plus 10,
70.
plus 5,
75.
75 plus 10,
85.
plus 5,
90.
90 plus 10,
100.
100, 100 plus 5,
105.
105, 105 plus 10, 115 plus 5, 120, 120 plus 10, plus 5, and 135 plus 10, plus 5, 50. Okay. So, that's what we're doing on the next page. It says record the next 4 multiples she wrote down. So we've got 105, 120, 135, and 150. What do you notice about the ones place of all those digits?
Oh.
Athena?
Every other one is a 5.
And every other one is a
0.
yes. So they alternate 5, 0, 5, 0, 5, 0. So that means they are multiples of 15. What else are they multiples of, Autrey?
5.
5. Because on our 5 row, it's 5, 10, 15, 20, 25, all 5s and 0s. Okay, so that's a pattern. This is kind kind of cool. What do you add to 1 to get 3?
2. 1.
And then what do you add to 3 to get 4?
1.
What do you add to 4 to get 6?
2.
What do you add to 6 to get 7? What do you add to 7 to get 9?
2.
What do you add to 9 to get 10? You see what the pattern is?
Yeah.
For the tens place, plus 2 plus 1, plus 2 plus 1, plus 2 plus 1. I do like that one. Fisher likes patterns too. I can tell.
Like red, black.
Like go Pirates go. Okay. Choose one pattern that you noticed and explain why you think it happens. We'll come back to that. Could 250, if we kept going, would we eventually say 250? Let's see. So we're doing multiples of 15. Can we multiply 15 times anything and get 250?
Yes.
Well, but let's think it through. Okay, can you multiply 15 times anything and get 2?
No.
Can you multiply 15 times anything and get 25?
No.
No. First multiple's 15, second's 30. No 25 in there.
So no, you would never reach it.
So could 250 be a number? No. 250 is not a multiple of 15. And I could keep going to confirm. This would be 165, 180, 195, plus 10, 205, plus 5, 210, 225, 35, then 40. Add 10, 250, 255. So not 250. Okay. Okay. Section summary. In this section, we looked at different patterns of shape, or different patterns of shapes and patterns of numbers. We saw shapes that grew, or repeated by certain rules, and we used numbers to help us see how the shapes change. Here are some examples of patterns. Shapes that grow by a rule. Add 1 row of equal size squares. So this has 2 rows, plus 1 more row, plus 1 more row, plus 1 more row. You could also do a pattern of area. So how many boxes are there on the first one? 4, 6, 8, 10. Okay? This is going to be similar to your quiz. You're going to have to identify the numbers and find the rule. Shapes that repeat by a rule. Triangle, circle, triangle, square, repeat. And then you can assign numbers to help you figure out the pattern. So if we're doing all the triangles, 1, 3, 5, 7, 9, 11. If I ask you, on the triangles, would it never have a number 20? Nope. Why not? 1, 3, 5, 7, 9, 11. What kind of numbers are those, Ari? Odd. And what kind of number is 20? Even. So we would never say 20. And then these we know, we did the area and perimeter both on these. And we learned to extend patterns by first finding their rule. Sometimes we can use addition and multiplication to represent a rule and then extend the pattern. Other times we can see how the digits and the numbers change to make predictions. All right, so lots of pattern stuff. So I'm going to stop the video and go back so you guys can finish copying this stuff down. This is what you need to write on this page, on I think you flipped one too far.
I already finished it.
So we are adding 100, then subtracting 1. So the hundreds place goes up by 1, the tens place stays the same, and the ones place goes down by 1.
I finished. Can I do the passage?
Mm-hmm.